In this video, I'll be working through the question you can see on the screen from the Cambridge A-Level Maths Paper 1. Specifically, it's Paper 1-1 from the winter exams in 2023. If you're looking for a different question from this paper, there should be a link to a playlist with all the questions below this video. I'm doing this on a whiteboard. Hopefully it'll be like you're used to your teacher doing. And if you do find this or any of my other videos useful, I'd greatly appreciate it if you like, subscribe, or even share it with a friend that's doing the exam this year or next. In question 8, we're given these two equations you see here, which make these two curves that you see here. And question 8 is not an easy question, but it is a straightforward question. And what I mean by that is, it is something you will see regularly. They simply ask us to find the points of intersection of the two curves, something you will see regularly. And then they ask us to find the area between two curves. Again, a question that will come up quite regularly. So let's just jump into it. Part A asks us to find the points of, the coordinates of intersection. I'm not sure how they say it. The A and B here, the points of intersection of these two curves. So we do that like we always do. We put the curves equal to each other and try and solve for x and y. Now one thing they did tell us, they gave us a hint to use u is equal 2x minus 3 to substitute this into it, and it will make this a lot easier. And it will make it a lot easier. So if we substitute that into these two equations and put them equal to each other, we would get this top one here would become u squared plus 1, and equals this one would become 2u to the power of 4. And that might not be clear, but this is a quadratic equation. Let me rearrange it and hopefully it'll become clear. Move everything to the right, we get 2u to the power 4 minus u to the power 2 minus 1, and we'll move the equals to the right as well, and equals 0. That's a quadratic equation. It's just, instead of x being squared, it's u squared being squared again. So think of this as u squared squared. This is u squared on its own, and this is a number on its own. That's what a quadratic looks like. This quadratic factorizes quite easily. If you're not good at factorizing, use the minus b formula. There's no shame in it. So u squared times, 2u squared times u squared. The only way to make 2u squared, u to the power 4. And then 1 times 1, only way to make this, again, if it's a simple factorization. To make the minus here, we would need minus 2 plus 1. So minus 2 we'll get from here, and plus 1 will come from here. That solves it. We get u squared is equal minus a half, and we get u squared is equal to 1. Now, you might lose a mark here if you do not tell the examiner that you know this is impossible. You need to just put a line through that or something. Tell them that's impossible. You can't have something squared equaling a minus, being negative, unless we're in the complex world, which we're not. Anyway, we're not solved yet. U squared equals 1. That means u is equal plus or minus 1. But again, we're more worried about x and y. So let's instead of u, let's put in the x's. 2x minus 3 is equal to either 1 or 2x minus 3 is equal to minus 1. Let's split the world in half here. Rearrange this, we get 4 over here. 2x equals 4, so x equals 2. We would get 2 over here. 2x equals 2, so x is equal to 1. There are your two answers. So many students leave that as their answer, and they're throwing away a mark. They didn't ask you to find x and y. They didn't ask you to find x only. Even though it is all we need to answer the rest of the question, they asked you to find the coordinates. So they want to know the y number up here. And it should be clear actually it's the same number. But still, we'll see that in a moment. Pick either of these you want. The top one is a squared, so it seems easier. Y is equal to, let's see, what happens when we put 2 in here? 2 times 2 is 4. 4 minus 3 is 1. That's good, that's an easy number. 1 squared is 1. 1 plus 1 is 2. We get 2. So the first coordinate, this coordinate over here, B, is 2, 2. And the next one, we should already know it's going to be 2 because we can see that, it's obvious. But let's put it in anyway. 1 goes in, 2 ones are 2. 2 minus 3 is minus 1. Minus 1 squared is plus 1. 1 plus 1 is again 2. So we get 1, 2. That is the answer to part A. That's both coordinates, 1, 2 and 2, 2. Let me go ahead and rub all this off and we'll start into part B. Okay, in part B, they ask us to find the exact area between, shaded area here, the area between these curves. So there is a few ways to find area, to guess at an area, to estimate an area. But when they say exact, you should be thinking integration. When they say area and curve, you should be thinking integration. With that said, there's 2 ways to do this, which really work out to be the same way. Lots of students like to break it into 2 questions. Get the area under the top curve, then get the area under the bottom curve and take them away. That would look like, let me write it up here actually. A is equal to the integral of 2x minus 3 squared plus 1 dx, minus then the second number would be the integral 1 and 2 of 2 times 2x minus 3 to the power of 4. That's a lot of students do it this way, that's fine, it works out perfectly okay. And then the other way to do it is to just get the area between 2 curves. And that looks like, it nearly looks identical. That looks like it's one integral. It looks like the top curve, 2x minus 3 squared plus 1, minus the bottom curve, 2 times 2x minus 3, and all of that is one integral, dx. So these are identical. We got the same term, minus a minus, the same term here. In fact, what I'm going to answer, I'll rub this all out and do it again. How I'm going to answer it is, I'm going to break this into 3 questions. I'm going to do the integral of 2x minus 3 squared, I'm going to do the integral of 1, and I'm going to do the integral of 2 times 2x minus 3, sorry, it should be a 4 up there, to the power of 4. I'm just going to do 3 different parts, which would be just like doing either of these. So whichever way you do it, you should be getting this sum, and this sum. This is a plus, and this one's a minus. Okay, let me clean this off, and I'll just leave this sum written over there somewhere, and we'll do it all in one go. Okay, however you arrive to it, this is the 3 integrals you should be doing. And I'm going to do each of these separately because I'm going to use substitution on the first one. Same substitution we had from earlier. And then for the last one, I'll do that one in my head because a lot of students do it in their head, just to show you what you can do once you get a bit of practice. But really, both of these can be done using substitution. So let's just do this in 3 different parts up here. The first one, the integral between 1 and 2 of 2x minus 3 squared dx. We can write that instead, using substitution, we can write that as the integral of u squared. But I need new numbers and I need to change the dx. So how we do, and we do this every time we do substitution with integration. We differentiate over here, the u dx is equal to 2, and that disappears. And rearrange this so we get what dx equals. Dx is equal to a half du. This is not technically correct. If you go to college and do multivariable calculus or anything, this not technically correct, but I don't remember enough to tell you why it's not technically correct, but it works. That's the most important part. So instead of dx here, we're going to replace it with a half du. So du is here, and we'll put the half out front. Instead of these numbers, let me just leave it blank for now, because I'm actually just going to put the x back in later. So these numbers will work fine later, but what you could do is put in 1 and we get a minus 1. Yeah, here, I'll put it in just for now. I won't do it every time though. Minus 1, and we put a 2 in and we'd get a 1. But still, I'm not going to do that every time. Okay, so integrate this one. This is a lot easier to integrate. The half is out front. U squared becomes u to the power 3. We take the 3 and we divide by it. So 1 over 3. And that's it. And that's between two numbers, these two. But let's just put the x's back in. So that becomes 1 over 6, half by a third, times 2x minus 3. And that's evaluated between 1 and 2. So that's it. We've integrated that. We'll do the evaluation later. Let's put this in under here. 1 over 6, 2x minus 3 to the power of 3. Right, the next sum we need to do is the integral of 1. Very common one, and it's one students mess up all the time. But it's the integral of 1 is just x. Again, between 1 and 2, between 1 and 2. So let's put that in, plus x. And the last one, and again I'll do this quickly without substitution, although you can use substitution. First of all, the 2 can come outside. It's just a constant. So 2x minus 3. Sorry, I'll keep leaving out that power of 4. To the power of 4 dx. So we can integrate this in our head using the chain rule. Well, using integration with the chain rule. If we imagine this bracket is just a u or anything, we'd integrate that like the 2 would be out here. This bracket, 2x minus 3, would just go up a power. So it'd go up to 5. And then we'd divide by a 5. Now we cheated there. That is cheating. We can't ignore this bracket. And the chain rule fixes that though. And all the chain rule needs to do is differentiate in here and then divide by it. So differentiate this, we get 2 and we divide by 2. So let's put in another 2 here. And that should look very familiar to substitution. We differentiated and divided by 2. The power of the u went up. This is identical to the substitution. I just did it quicker in my head. Okay, I'll clean this up. The 2's cancel and I'll put it in over here. Remember, this is a minus all along. So we'll put a minus in. Minus 1 over 5 2x minus 3 to the power of 5. Let's continue this in over here, because this is all evaluated. Put a bracket around it. It's all evaluated between 1 and 2. So we can just go ahead and put 2 in. We put 2 in first, and then we change everything to a minus and we put 1 in. That's how we evaluate. And it should be quite easy, because we've already seen what happens when 2 and 1 goes into these complicated looking things. They come out as 1 and minus 1. So let's put 2 in here. 2 2's are 4. 4 minus 3 is 1. 1 to the power of 3 is 1. So all of that comes out as 1 over 6. This first term when 2 goes in. When 2 goes in here, we get a 2. When 2 goes in here, we get 1. 1 to the power of 5 is 1. We get minus a fifth. Okay, change this to a minus and then put 1 in. 1 goes in. 2 1's are 2. 2 minus 3 is minus 1. Minus 1 to the power of 3 comes back to minus 1 again. So the whole thing's minus times minus 1 times a sixth. We get 2 minuses, we get a plus a sixth. X, it's changed to a minus and we put 1 in. Simple. Okay, we have a minus. We change the sign to a plus and we put 1 in. It becomes a minus. It becomes minus to the power of 5, which is a minus. So minus, minus, another minus. We get a minus 1 over 5. And that's it. We just put these in your calculator. You don't have to do them yourself. We get 14 over 15. You can do that by hand if you want, but just throw all them in a calculator. And that's the answer. That's the exact area between these two curves. 14 divided by 15. Okay, I hope that helped. If you have any questions, like I said, it's quite a standard question. It's long, it's messy, it's difficult, but it is quite standard. So if you have any questions, let me know. I'll do my best to answer you. Thanks for watching and have a great day.